Hello guys, so today we are solving the Leetcode POTD minimum increment to make array unique. Okay, it is a medium level question. You are given a integer array nums. In one move, you can pick the index I where I it belongs to 0 to nums dot length. Okay, and increment the nums of I by 1. Okay, so we are given a one array. Let us say A. Don't say it nums. Let us say it's the array A, and we have a one operation. Operation is that you can choose any index I between um, 0 to n minus 1. Let us say they are choosing one base indexing, so but we are working on the zero base indexing. So we are choosing the index I between the range 0 to n minus 1, and what we are doing is we are increment the a of I by 1. Okay, a of I is equals to a of I plus 1. This we can do in one operation. Okay, then what is our task is, let's read. Return the minimum number of moves to make every value in num unique. Okay, so we have to make the array A unique. Okay, every element in the array A must be unique. Okay, so is the minimum number of way, what is the minimum operation that are required to make to do this, that is our task. Okay, what is the minimum number of operations that are required. So this is a optimization problem, we have to minimize the operation. Okay, so let us say the second test case is 3 1 3 2 1 2. Okay, 3 2 1 2. Okay, and 1 7. 3 2 1 2 1 7. So this is the array given. Now you can see that there is some element which are the duplicate elements. You can see here there is a one element which is duplicated, there is a two which is duplicate here. Okay, so we have to increase this element or this element. Okay, we have to change this element. Okay, so that my array becomes unique. So you have to change the duplicate elements. Okay, you can see that you have to change the duplicate elements so that every array becomes unique. If the element is duplicated, then what you are doing, you have to simply keep the one element as it is, but which is in the second duplicate, you have to change it to the another number which is not present in the array currently. Okay, so now you are seeing that 1 is present, 2 is present, 3 is present. So you can make that 2 equals to 4 or 1 equals to 4. So, okay, 4. Okay, then you can make 2 equals to 4. Let us say you are making 2 to 4. Then what is the number of operations that required? You have to increase it by 2. Then it becomes 4. And let us say now 4. Now 4 is in on the array. Then you have to increase the 1 by 5 to till 5. Okay, so you have to return it the plus 4. So in the plus 4, you have to, the element is become 5. Now you can see that there is a 1 2 3 4 5 and 7. Okay, all elements are the array unique. So what is the number of operations that we are required to do this? The number of operation is plus 2 and plus 4. So number of operation to do this is equals to 6. Let us say it is correct or not. Okay, the number of operation is to do this is equals to 6. Now that comes to the algorithm. What algorithm you apply here to do this optimization? So what if my both duplicate elements are adjacent to each other? What arrangement I can make into the array such that my duplicates element are both, my all duplicates element are in a adjacent to each other, and my then second duplicate element are adjacent to each other, and the third duplicate element are adjacent to each other. What should I do with my array A so that my array A elements are arranged in this order? Okay, that is perfectly right. You can figure it out. This is the sorting algorithm. If you sort the array, then whole array elements are in the sorted order. Let us say 1 1 2 2 3 and 7. Then you can see that whichever element is the duplicated, they are comes adjacent to each other. Okay, okay, there is a 2 2 which comes duplicated, there is a 1 1 which is comes together. Okay, now what you have to do, you have to simply check if my current element is equals to my previous element. Okay, let us say let me write it in a, okay, 2 2 3 and 7. Okay, then what will I do? I will simply check iterating this array. Okay, and simple check if my current element is equals to my previous element. If my current element is not equals to previous element, then what will I do? I will simply increase it to my last elements by 1. Okay, let us say now I'm currently standing at the this one, but there is a no previous element, so I will simply increase to the next index. Then this is, then you can see that there is a matching with the a of I minus 1. Okay, my previous element and my current element are same, but our target is to make it unique. Now you can know that you have given that the array is sorted. Okay, you have sorted the array. So whichever element is comes before my ith index are always less than or equals to my current index. Okay, you can agree that whichever element in the comes less than or equals to my a of I. Okay, if my index is less than I, then every element which index is less than I, they are always less than or equals to my current index. You can agree that because the array is sorted in the increasing manner. Okay, you can say that the non-decreasing manner. So that this is hold always true. Okay. So what you can do is to make the element equal, to make the element unique. If your current pair is matching, you can see that there is a current element is equals to the previous element. Then what you are doing, you are making the current element to the previous element plus one. Okay. Now the previous element is one. Now you can make the current element to the previous element plus one. That is equals to two. And what operation are required to do this? The operation required to do this, the new element that become new element minus the previous minus the current element, that is current original element. Okay, new element minus original, new element is equals to 2 and current element now is equals to 1, then the answer is 1. Okay, now simply moves to the next. Okay, now simply moves to the next index, that is equals to 2. Now I am currently storing this to 2. Okay, now I will update also I will update also in the array also. Okay, now I will move to 2. Then what you are finding that my current index is equals to my previous index. Then what will I do? Less than or equals to. Okay, it is also there. If your current element is less than or equals to your previous element, then you have to also do the operation. Okay, so what is the algo that you are following? Let me simply write it. If in traversing your array of element is less than or equals to a of I minus 1, if this is hold, then you are adding your current a of I is equals to. Okay, then you are what you are doing, you are adding the current a of I. Let us say the new element, that new element you are required is a of I minus 1 plus 1, because you have to make this element unique. Okay, so a of I minus 1, and what you are doing is you are simply adding what is the operation. Okay, let's forget this. Okay, what is the operation that are required? Operation that are required is a new element minus the current element, and after this you are adding this operation that are required is plus or equals to new element minus current element, and after this you are updating your current element to new element. Then you will move ahead to I plus 1. Okay, this is the algorithm you are following while the whole traversal in order of n. Okay, so let us say now currently you are standing at 2, and the 2 is also done. Then you have to make this element to 2 plus 1, 2 plus 1, then 2 plus 1 equals to 3. Okay, so what is the, okay, let me erase this. Okay, then what is the operation that are required to do this? Then operation that are required here is the one operation to required to do this, and here you are required the one number of operation. Okay, now you simply update it to 3 and you were moving ahead. Now you are standing at 2, you're checking that if the previous element is greater than or equals to current element. Yes, then what you are doing, you have to make this element to this plus 1. So my current new element is become 4. Then what is the operation that are required? This is 4 minus 2, then it will come 2. Now it becomes 2. Then I will simply update my element to 4. Then I will move ahead. Then I comes to 3. Let us say if my previous element is greater than or equals to not. Yes, it is greater. Then what I have to do, I have to make it to 4 plus 1 equals to 5. What are the number of operations that are required? 5 minus 3, that is a 2 number of required. Then I will simply update my current element to my new element. Then I will move ahead. Now I am standing at 7. I am looking for if my previous element is greater than or equals to my current element. No, this is not there. Then I will not update any current element, and I will not add into my operation. Okay, so what is the operation that are required? I will sum it up the all operation and I will return it. What is the operation? 2 plus 2, 4, 5 and 6, and the number of operation is 6, and you have to return this, and this is your answer. What is the time complexity of this algorithm? Time complexity of this algorithm is big order of n log n to sort the array, and other of order of n for traversing the array and finding the operation. Okay, and what is the space complexity? Space complexity of this algorithm is big order of 1, because we are not using any extra space, either a vector or a map or a set. Okay, we are not using any extra space. Okay, so it will take only big order of 1. Now let's come to the coding part. What we are firstly required to sort the array. Okay, let us say the array is a. Now sort a dot begin to a dot end. Okay, we have sorted the array. Now what I will require is the number of operation is equals to 0, and I will simply traverse till index 1 to index n. But what is n? So we have to initialize our n. Here n is equals to a dot size. Okay, now what I will be checking is if my current previous element is greater than or equals to my current element. If it happens, then what I will do, I will simply assign my new element is equals to my previous element plus 1. Okay, this is my new element, and I will add it to my operation. Whatever operation are required, new element minus current element. Okay, this number of operations that are required, and I will simply update my current element to new element. Okay, after the whole algorithm ends, I will return my operation, number of operations that are required to do this. Okay, let's run it. Okay, it is working fine. For the sample test cases, what is the time complexity? This sorting take big order of n log n, and this loop takes big order of n. So the time complexity of the whole algorithm is big order of n log n plus n. So it will approximate it to big order of n log n. And what is the space complexity? Space complexity, we are only using this integers variable. This is taking constant space. So space complexity is big order of 1. Okay, this is all about it. Let's submit it. Okay, is accepted. So this is all about the minimum increment to make array unique. Thanks for watching. See you tomorrow.